Hello, my name is Hedda and I did my fellowship project with faculty on causal marketing. Machine learning is really great in doing predictions, but we want to know what is the action that we should take afterwards. So, for example, if we want to maximize our profits, what is the action we should take, or what is the intervention that could get us there? Is it a voucher or some other email you could send? So, in the context of consumer business, faculty has already worked on taking predictions and kind of translating them into a definite action for customers. So my project is based on this work, and I will answer the question, what is the best action you can take if you have multiple marketing interventions available? So in summary, we want a model that for each individual kind of tells you this is the intervention you need to maximize your profits. You can use this in a marketing setting, but you could use this as well, for example, a medical setting. If there is a clinical trial, you can use this to say what is the best treatment for this specific patient. But we looked at the marketing example. The data that we had was a customer base from the last 12 months, and it was people bought merchandise. We do know whether they bought merchandise for women or merchandise for men. This data had 3 different interventions. So there were 2 different emails that could be sent. So one email for merchandise for men, one email for merchandise for women, or sending no email at all. All these interventions were randomly distributed. And the dataset told us as well whether people after this intervention, within 2 weeks, visited the website and bought something. When we distribute the interventions randomly, we will have good decisions and we will have bad decisions. There will be people who got an email and got really annoyed and did not buy anything, and there will be people that got the wrong email, and there will be people that got an email and were super happy, immediately went on the website and bought something. So we want to compare our model, of course, to benchmarks. So the benchmarks that we have here is a simple segmentation or a random allocation. So remember, we do know what the people bought before. A simple segmentation would be saying someone who bought merchandise for women probably wants to have an email about merchandise for women, and the same for men. So this would be the simple segmentation. A random allocation is just randomly sending emails out or not. The objective for us, of course, is we want a model that outperforms these benchmarks, and we want to find a suitable metric to say, is this a good model? And I don't want to give too much away, but the model does outperform all these things. Just saying. One question is, of course, how are we going to measure it? Because as I said, with the randomly distributed interventions, we have some really bad decisions in there. So we don't want to reproduce the data, but we want to know, did we catch the good ones? And if there was a bad intervention, did our model propose something else? So there is a metric that kind of gives you a value for this. Just as a side note, we counted going to the website as a success. The website signal was a lot stronger than the purchase signal, and after all, if you want to buy something, you have to visit the website first. We tried many models, from random forest to XGBoost, and different ways how to ingest information about the interventions called learners. And in all these models, the best model had more than 18% visits after getting an email. The comparison to the simple segmentation, it was about 17%, and when we look at the random allocation, it was just a little bit less than 15%. But we want to put this all into numbers. If we compare this, our model had extra visits of 2,000 extra visits compared to the simple segmentation, and compared to the random allocation, extra 6,000 visits. And we want to have more numbers. The data told us that about 6% of the people who visited the webpage actually bought something. And on average, they bought something worth $120. So if we combine this all, we can say that our model, compared to simple segmentation, had a profit of more than $14,000, and compared to random allocation, it was even more than $43,000. So in summary, our model outperformed kind of commonly used techniques to allocate individual interventions. So thank you very much.